So to solve quadratics, there are lots of different methods. There's the quadratic formula, there's completing the square, there's looking at the graph, there's lots of ways. So I'm going to show you and remind you of all those different ways, and then then you can start seeing the way that works best for you. Let's talk about the quadratic equation. If you have a quadratic equation, or if you have a quadratic that you want to solve, and it has to be in the form ax squared plus bx plus c equals 0. So that's what you're trying to solve. What the quadratic formula does is it gives us a way to solve that. Did we go over it anywhere else? No. Okay. So that is a quadratic equation. And the quadratic formula is one way that we can solve it. So let me tell you what it is. It's negative b plus or minus the square root of b squared minus 4ac all over 2a's. We will practice using it, but I want to make sure that you see it. And I want to talk about some things I notice as a teacher that sometimes students will make a mistake when they're doing it. You want to think about that as the opposite of b. Now, b is the coefficient on our x. You want to do b squared minus 4ac. You want to get a value before you square root, okay? So it is the square root of that thing, of that answer. So get that down to a value before you try to do anything else. This is a division bar that is under the entire quantity on top. So you'll sometimes hear it read negative b plus or minus the square root of b squared minus 4ac all over 2a. That just reminds you you're going to divide this entire quantity by 2a. Now the plus or minus occurs because of the fact when you try to do something about that, then you can do something called completing the square, and when you take a square root you get a plus or minus, and that's where this formula comes from. Okay, so that's a formula we will use here and there. We're going to start out slow with quadratics and talk about the square root property. So if you have something like x squared equals a, and you want to solve for x, excuse me, you want to undo that square, which you all probably recognize is a square root. But when you do that, when you inflict that square root on the a, please, please, please remember to include a plus or minus symbol in front. Now, why does that happen? Well, if I square positive 1, I get 1. If I square negative 1, I also get 1. Now, I'm talking about it's included in parentheses, so 1 squared is 1. Negative 1 squared is also 1. So that's why that plus or minus thing occurs. You have two possibilities. So it's essential. You will get it wrong in Alex. You will get it wrong for me if you do not include that plus or minus in front of the square root. So if you have inflicted the square root, you put a plus or minus. If there was already a square root in the problem, you either had it or didn't, okay? But if you put the square root on, you have to include the plus or minus, okay? So when we're looking at this first problem that says u squared equals 81, and we want to solve it where u is a real number, simplify your answer as much as possible. The first thing we're going to do is we're going to take off the square on the left. We're going to plus or minus the square root of the right. That looks really yucky. So when you plus or minus the square root of 81, you just got to remember how to reduce a square root. So they want you to reduce it as much as possible. So, if it's a perfect square, great, because 81 is 9 squared. So So that would just be plus or minus 9. Now, here is where Alex, I just want to remind you, let's read these instructions right here. See right here, it says, if there is more than one solution, separate them with commas. If there's no solution, click on no solution. Well, there is more than one solution. So I would probably write -9, 9 for Alex, okay? I don't think they have a plus or minus button, but look and see. I don't know. I have no idea. Okay. Any questions about that square root property in that first problem? Okay. Now here is a square root problem where we don't necessarily have a real number solution. So see this right here? It says a real number solution. So let's do the math, and then I'm going to show you what I want, and I'll show you what Alex wants. Okay. When you go to put that plus or minus, the square root is over the entire thing, the entire -20. So for me, since -20 is -1 times 4 times 5, the -1 comes out and is represented by an I. The square root of 4 comes out, it becomes a 2. And then the 5 is stuck inside. So that's what I want, okay? That's what I want. I want plus or minus 2i squared root of 5. Okay, so that's my answer. But look what Alex is asking. It says where x is a real number. See that right there? This number is imaginary. It is not a real number. So in this particular case, for Alex, you would say no solution. Because there is no solution that is real. For me, I want that imaginary solution. Now, there might come a section where Alex says any solution, real or imaginary, and then you type in the I solution. But if it just says a real solution, there is not a real number in that answer. I is not on our real number line. It's not a real number. It is imaginary. So if you take a square root of a negative and Alex says to give any real number solutions, there is no real number that is represented here. Does that make sense? The difference about the two things. So for me, if you said no solution, you're wrong. I need that I need to see the algebra of it. But if Alex wants it and they're only asking for real numbers, just be careful, okay? Okay. Now let's talk about one where factoring is involved, okay? Now, we're going to start out with very simple factoring. Do you see here? It says ax squared plus bx equals 0. Now, the a and the b might have a numerical component that is alike. I don't know that. In this particular case, I don't know what a or b is. So they might both be divisible by 2, take out a 2. If they're divisible by 7, take out a 7. That's what I mean. But what variable do they both have? What variable do we see? Yes, it's got an x, right? So if there's an x there, that means it's always factorable. So you can always take out an x. So what's really cool about that is if we take out that x, there is something called the zero product property. That means if two things were multiplied together to equal 0, you will find a solution where the first thing equals 0 or where the second thing equals 0. So this means that x could equal 0 or ax plus b could be the thing that's equal to 0. Either one will work. You can split it apart, then you get two very simple formulas or equations to solve. This could be, you could apply the quadratic formula to that. A and B go into the formula like normal, C would be 0 because there's no C value. So if you don't see a C value, it's 0, if you wanted to use the quadratic formula. But when we get to, we'll get to the quadratic formula eventually. So let's look at the example. It says 5w squared plus 10w equals 0. Solve for w. Now, in that case, I think one of the most effective ways to solve a quadratic is to factor it if you can. What is a number that can be factored out of 5 and 10? What are they both divisible by? 5. So we can take out a 5. Do they have a variable in common? Yes, the w. What's the lowest value or lowest power? 1. So that means I can factor out, divide out a 5 and a w to the lowest power, to the first power. Now, when you do that, you just have to use your rules of division. For the number, you just divide it. For the variable, the power is going to go down by 1. And so this would be w plus 2. Now, you can check your work. The opposite of division or factoring is multiplication. So you could just do a little mental check. If I distribute back in, I better get 5w squared plus 10w. So that's just a very simple check in your brain. You know, did I do the correct division? Okay. Now what's cool is we can separate them. 5w equals 0 or w plus 2 equals 0. And they become just very simple things to solve, right? For the 5w equals 0, if you divide both sides by 5, 0 divided by anything is still 0. And ones that have just these two terms like this will always have a 0 in there. And then here, that would be negative 2. So if there's more than one solution, separate them with commas. So you would probably go for Alex, negative 2, 0, or 0, negative 2. If they say, sometimes I've seen that where they said to put it in least to greatest order. Just be mindful, read those instructions before you enter it. You don't want to get it wrong when you actually have the correct answer. Any questions about factoring to solve? Okay. So let's talk about the homework for a moment. Okay, we're going to do just a few little ones to get started. These ones here is that square root property. So once the square root is by itself, like these 4, you can just square root the number. Don't forget the plus or minus in front. Reduce the square root as much as possible. But let's do number 5. What's different about number 5 compared to the first 4? Yeah, it's got that plus 8. It's not, you know, just the squared equals a number. So you can fix that very quickly by subtracting 8 from both sides. Now, to get rid of the square, we're going to square root, but don't forget, you got to put the plus or minus in front. And then I want that reduced down as much as possible. 20 is 4 times 5. So I can evaluate the square root of 4, but leave a 5 behind. And so remember, the square root of 20, that's 4 times 5. So the 2 comes out, the 5 is stuck. Okay? So that's how you're going to do the first 6. If you get an I, show me the I. Okay? If you get an I, which would be a square root of a negative, show an I on the problem. Okay? Now, for the ones they did by factoring up above, they were pretty, they'd already, you know, they wanted you to factor out a W or whatever that was. Here, these ones are already factored. We're going to explore more complicated quadratics eventually. But here, I just want you to get in the habit in 1 through 4 here, is if they are in parentheses already, they have got factored already, then they've done most of the work for you, because what you can do is you can split them apart and set each piece equal to 0 and then solve each piece individually. So that's what I want to see for 1 through 4. I want you to split it apart and then solve each one individually. And then when we do part 2.5b next, we'll start practicing using some more of those formulas and some more complicated type quadratics. So this one is just kind of an intro, and then tomorrow we'll dive in a little deeper. Do we have any questions about what you need to do? Yes. Yes, please. So for number 6, it was noted that we've got that negative there. So first divide by 2. And then when you take the square root, you are taking the square root of the negative. So that is not done. I'm going to let you try it. But the way that you have to do it is the negative becomes an I. And then what's hiding in a 72 that I can remove? So there is a perfect square that divides into 72 that you can take out. Okay, there's actually, so if you think 4, that's okay. If you think 9, that's okay. But there's a bigger one than both of those too. Anyway, so work on these for the remainder of class. If you get stuck on any, let me know. We can do them together. There you go.